everyone, this is Daisy Margaret.
In today's video, we are about to discuss Class 8, Unit 9, Matter Around Us, Part 3. Topics to be discussed: metals and non-metals, properties and uses of metals, properties and uses of non-metals, and difference between metals and non-metals. Metals and non-metals. The progress of man towards civilization is linked with the discovery of several metals and non-metals. Even today, the index of prosperity of a country depends upon the amount of metals and non-metals it produces. The wealth of a country is measured by the amount of gold in its reserve. So we are going to discuss about metals and non-metals. So the progress of man towards the civilization is linked with the discovery of several metals and non-metals. So what is civilization? It is the advancement or a process or wave of life. Okay, so the progress of this civilization is linked with the discovery of several metals and non-metals. Even today, the country depends upon the amount of metals and non-metals it produces. The wealth of the country is also measured by the amount of gold in its reserve. An element can be identified as metal or non-metal by comparing its properties with the general properties of metals and non-metals. So, how an element can be identified whether it is a metal or non-metal? It is compared with its properties with the general properties of metals and non-metals. In doing so, we find that some elements neither fit with metals nor with non-metals. So, such elements are called semi-metals or metalloids. So, some of the elements it will be neither fit with metals or nor with non-metals. So, we consider those elements as semi-elements, or those elements are called as metalloids. Elements are classified into metals, non-metals, and metalloids based on their properties. So you can see here metals, non-metals, and metalloids. The elements are classified into metals, non-metals, and metalloids based on their properties. Metals: iron, copper, gold, silver, etc., that we use in our daily life are metals. The properties and uses of metals are given below. So, the metals iron, copper, gold, and silver we use in our daily life, so they are called as metals. So, the properties and uses of these metals are given below. So first we are going to discuss about physical properties of metals. So metals are solid under normal conditions of temperature and pressure. Most metals are hard, all metals are shiny. So metals, they are solid under conditions of temperature and pressure. Most metals are hard and all metals are shiny. The typical shine of metals is called metallic luster. Metals generally have high density. Metals in general have high melting point and boiling point. Metals can be hammered into very thin sheets. This tendency of metals is called malleability. So, what is a metallic luster? Property of a metal that describes amount of light that reflects off the metal. So the typical shine of metals is only called as what? Metallic luster. So density is, it is the amount of mass per unit volume. So the typical shine of metals is called metallic luster, and the metals generally they have high density, that is The density is amount of mass per unit volume. And also, in general, metals have high melting point and boiling point. So what is melting point? Melting point, it is the exact temperature at which substance changes from solid to liquid. What is melting point? Melting point, it is the exact temperature at which the substance changes from solid to liquid. For example, your ice cubes, it is in the solid form. So at the exact temperature at which your ice cube changes from solid to liquid, so the ice cube, when it starts to dissolve into liquid, that exact temperature is called as melting point. Boiling point, it is also the temperature, the exact temperature at which the substance it transfers from a liquid to the gaseous phase. Okay, so that is the boiling point. So metals in general, they have high melting point and high boiling point. So next one, what is malleability? So malleability, it is the property of a material by which it can be beaten to form thin sheets. So metals, they can be hammered into very thin sheets. So hammering the metals into very thin sheets, this tendency of the metal is only called as malleability. Using this property, aluminium is transformed into silvery foils. Metals can be drawn into thin wires. This property of metals is called ductility. So, example, copper wires. So, using this property, aluminium foil is transformed into silvery foils. What property? Using the malleability property, the aluminium is transformed into silvery foils. Metals can be drawn into thin wires. Okay, even the metals can be drawn into thin wires. That property of metals is called ductility. So what is ductile? It is the property that describes the ability of the material to stretch thin when tensile strength is, or when tensile stress is applied. Okay, so this is called as ductile, the property of the metal. Okay, it describes the ability of the material to stretch into thin wires. Okay, so example, we have copper wires. So, generally, metals are good conductors of heat and electricity. So, we use copper wires in the most of the wires, since they are good conductors of heat and electricity. So, metals, they are good conductors of heat and electricity. On being hit, metals produce a typical sound. Hence, they are said to be sonorous. What is sonorous? It is capable for producing a deep or a ringing sound. So, this property is being made used in making temple bells. So, on being hit, metals produce a typical sound. Hence, they are said to be sonorous. Activity 1. Take a battery, few wire pieces, a bulb, a nail, and lead. First, connect the nail in the circuit as shown in the figure. So you have to take a battery, a few pieces of a wire, and a bulb, a nail, and lead. So first you have to connect the nail in the circuit as shown in the figure. So you have to connect a battery, a nail, and a bulb. Is the bulb glowing? Now connect the pencil lead in the circuit. What do you observe? So first you connected only battery, wire, and bulb. Now they are asking you to connect a pencil lead in the circuit, and you have to observe what is happening. When the pencil is connected, the bulb will glow. Thus, lead of a pencil conducts electricity. Lead contains graphite and it is a good conductor of electricity. So, what happens when you connect a pencil? The bulb will glow because the lead, it consists of a graphite. Okay, it allows electricity, so it conducts electricity. The pencil, lead of a pencil conducts electricity, so it is a good conductor of electricity. Thus, when you connect a pencil, that is when you collect a lead of a pencil, it will glow, the bulb will glow. Uses of metals. Iron is used for making bridges, engine parts, iron sheets, and bars. So you can see here these are the uses of metals. The iron, it is used for making bridges, engine parts, iron sheets, and iron bars. Copper is used for making electrical wires, coins, and statue. So you can see here copper wire. With the copper wire, we can use it for making electrical wires and copper coins and statue. So these are the uses of the metal copper. Silver and gold are used for making jewels and for decorative purposes and photography. Mercury is used in thermometers and barometers because of its high density and uniform expansion at different temperature. So mercury, it is used in thermometers and barometers because it has high density and uniform expansion at different temperature. Aluminium is used in electrical wires, cables, and in aerospace industries. So, aluminium, it is used in electrical wires and also it is used in aerospace industries. Lead is used in automobile batteries and in X ray machines. Non-metals, elements like sulfur, carbon, oxygen, etc. are non-metals. Some of the properties and uses of non-metals are given below. So we can see here elements such as sulfur, carbon, and oxygen. They are non-metals. Okay, even we have many more non-metals. So some of the properties and uses of non-metals we are going to discuss in detail. Properties of nonmetals. Nonmetals occur as solids, liquids, and gases at normal temperature. So, what is the property? First property, nonmetal, they occur as solids, liquids, and gases at a normal temperature. For example, sulfur and phosphor, they occur in solid state, while bromine, they occur in liquid state. So you can see here sulfur and phosphorus, they are in solid state and bromine in liquid state. So non-metals occur as solids, liquids, and gases at normal temperature. Elements like oxygen, nitrogen, etc. occur in gaseous state. So the elements like oxygen and nitrogen and many more occur in the gaseous state. Non-metals are generally not hard except diamond, a form of carbon. Non-metals have a dull appearance. Non-metals are generally soft and have low densities. The exception here is diamond, a form of carbon which is the hardest naturally occurring substance. So non-metals, they are generally not hard. Okay, so except diamond, It is a form of carbon, except that all the non-metals are not hard. So they have a dull appearance and they are generally soft and they have low densities. So the exception here is only diamond. It is a form of carbon, so it is the hardest naturally occurring substance. Non-metals have a low melting point and boiling point. So non-metals, they are non-malleable and they are non-ductile. Non-metals have low melting point and boiling point. Non-metals are non-malleable. Non-metals are non-ductile. Carbon fiber is highly ductile. Non-metals are generally bad conductors of electricity. So graphite, it is a form of carbon, so it is an exception. So non-metals generally they are bad conductors of electricity except graphite. Non-metals do not produce sound. They are non-sonorous when hit. Okay, so these are the two properties. So these are the properties of non-metals. Activity 2. Strike a metal utensil with a metal spoon. Note the kind of sound emitted. Now strike a piece of wood charcoal with the same spoon. What do you observe? Do you see the difference in the kind of sound produced? Most metals produce a ringing sound when struck if they are, that is, they are sonorous. Non-metals are non-sonorous. Okay, so most metal they produce a ringing sound when struck, that is, they are sonorous, and non-metals are non-sonorous. Uses of nonmetals. Diamond, a form of carbon, is used for making jewels, cutting and grinding equipments. Graphite, it is used in making pencil lead. Sulfur, sulfur is used in the manufacturing of gunpowder and vulcanization of rubber. What is vulcanization? The range of process for hardening a rubber. So sulfur is used in manufacturing of gunpowder and vulcanization of rubber. Phosphorus, it is used to make matchboxes and rat poison, etc. Nitrogen, nitrogen is used for manufacturing ammonia. Chlorine is used as a bleaching agent in sterilizing water. Chlorine is used as a bleaching agent and in sterilizing water. Hydrogen, hydrogen is used as a rocket fuel and hydrogen flame is used for cutting and welding purposes. Hydrogen is also used as a reducing agent. What is a reducing agent? A reducing agent is a substance that reduces a chemical compound, usually by donating electrons. We are going to discuss about the differences between metals and non-metals. So the property is given and the differences between metal and non-metal is mentioned. So the first property, physical state at room temperature. So for a metal, it is usually solid and occasionally it is liquid. For non-metal, it occurs as solid, liquid or gas. The physical state at room temperature for metal, it is usually solid, and for a non-metal, it may be solid, liquid or gas. Malleability, it is good for metals and it is poor for non-metals. In non-metals, it is usually soft and brittle. Brittle is, it is easily broken or cracked. Next one is ductility. So it is good for metals, and for non-metal it is poor because it is usually soft and brittle. Melting point and boiling point. So in metal it is usually high, and in non-metal it is usually low. Even the density, it is also usually in metal it is high, and in non-metal it is low. So melting, boiling, and density, that is melting point, boiling point, and density. In metals, it is usually high, and in non metals, it is usually low. Conductivity, thermal, and electrical. So, what is conductivity? Conductivity is, it is the ability to transmit heat, sound, and electricity. Okay, so conductivity is good in metals, and in non metals, it is very poor. These are some of the differences between metals and non-metals. Summary of the video: we discussed about metals and non-metals. We discussed about the properties and uses of metals and non-metals, and we discussed about the differences between metals and non-metals. The next video is about metalloids, physical properties of metalloids, and uses of metalloids.
If you like the video, please do like, share, and subscribe. Thanks for watching.